Okay, right now, the last with your post Sessie, with your eight, you know what I'm saying? I've been thinking about this, I mean, all of this, and I will say thank you for watching this channel. I did it with pleasure, you know, and yeah, we finally here. Maybe I will make some, I don't know, maybe vlogs for in the future, you know what I'm saying? I will see we see later. Okay. Exercise one right now. First step, what you have to do is just yeah, you have to know what it was, what the distance is and what the time is. Excuse me. So the first distance is 6.5 light years, 1 light years, just that. I will show you better with this one. So I know that I just named this like you can see this like Earth, It just mean that we are here that's the Earth. Distance is that, and then you have maybe a star, the star, there's a star, and then you know that this distance is just six point five, is the distance, from the Earth to the star. Okay, then you have the time. It will give us for me in my situation it was 3.2 years, the time to the earth to this, star, you know. Okay, let's get it. You have to use this, of course, to find my T, I mean this one. Okay, let's get it. So basically here you see that T1 is just my Earth, this time, and this one is just the time with my star, you know. And so here you just have to see, you know that this is just the yeah, you just have to use this. And what can I say? Go. Yeah, you can have then you can calculate this like this. We will find this, and it will give you this one. And then okay, that's for power B. For power B, you will have to use this formula. Maybe another color. I'm gonna use this one. Damn, what? Shall I leave this up? Gonna use this one. So first you have to use this one, and then But before I get further, don't forget to make to for each one you have to take this instead of light years. Just to mention, and maybe what you have to do here is just that's corrected. I think everything is here. You will be fine. Okay, next one. Next one. Okay, right now we're on the second exercise. Don't worry, should be almost finished. Um, so I sit here. Step one, two, step four. There is four steps. Just chronologic. So first step, what you have to do is just you have to know what this is. And we are already given this equation. So basically, just just do the equation thing there to find this f. So basically, it's f0 minus 0.0947 f0, and you will have this as a result. then you have to know that there is a Doppler shift, you know. Doppler shift, like it will say that when the object is going, well, how can I explain this? Okay, so imagine you're here and the object is here, you know, but the object is going away from you. So it's moving away from you. So it means that this is minus and this is plus. But if it was going to us, then it will be plus and this minus, you know, this plus and this minus. But because they say we very here, very important moving away, so you have to do mean and plus. And basically this one you will find this in your book. It's just a formula for double shift with light. Yeah, I think with lights, yeah, with not only with sound, but also already with all big stars, you know. Okay, then you have to apply this. Sorry, don't forget to do my C, but times C. Sorry, but later you have to do this. You have to put the C. Sorry, you have to put the C on the other side here. It will be then V over C, and that's what we're looking for. Okay, B over C. Okay, then you have F divided by F0. It's basically um just this also on the other side. I mean, no, just this one on the other side. So it will be one, you know, one. So one is equal to F over uh this over this, and you will have this one. You will have this one, you know, and then you have to do it in skirts, and you will get this one. So put this just like this, you know, and we have it. Okay, hope you understand this. Let's get it for the next one. Okay, right now we're in the third exercise, and the exercise is about let me shift it like this. Okay, so what I try to say is that we are talking about a particle, you know. This particle have a kinetic energy, and we are basically trying to find this I mean, wait, I will change my color. Red. Damn. Okay. Basically, we are searching for this letter, this mass, you know, this mass. And how did I did it? I just I just knew that the particle itself have a total energy, and this energy is splitting in two different energy. So basically, here you have the momentum, and you have also his light energy. So this one is likely also um kinetic energy, but also not is kinetic energy. It's a kinetic energy basically, and this one is just the energy that the a particle have. So this one is just for this thing, you know, and this thing you'll see. So what I did, because I know that this one was in quadrats, so you have to quadrate everything you see there, you know. And so when you have to use the squares for this term and this term, you will have this one. And so you just have to you just have to focus on this first equation and in this second equation, you know. Then you have to write like here, you know, to make it equal to each other, you know. And then maybe it was not so genuine for me. excuse me. I'll put this there. So what I did here is just so I was looking for the mask because I knew that here's my mask and here's also my mask, you know. So I was looking for this mask and just just so if you want to search this, these two will be canceled and the only mask that you will find is this one, you know. That's why I put this in this kind of formula. So this one, is here, is here. This one is just here, And maybe I forgot this one to do. I forgot to put this in the skirt. I will do right now if you want. It's my mistake, sorry. And basically what you have to do is just like this, you will have the solution. Okay. For the next one, next one. Okay, right now we are in the very, very last exercise number 4. What you have to do here is just the first step, you have to look at this one. Maybe I have to take this magical thing. So we're gonna use this one. Maybe another color. We're gonna use this one. Just we have to determine first the speed. The speed from so you have that's the Earth. I mean that's the Earth, and this is your even or equator, and they are moving from this point to this place, and that's why I choose my R, because the R was like the equator. This is my North Pole, because we already know that it is a circle, and why did I and divided by T? T is just I divided T in on one day. How do we say this? For one day, or many I mean yeah, for one day, how many seconds, So that's the thing provided to tell you, and this is the thing that you have to do. That's just the ray, the distance between the equator and the North Pole, and I use this formula. hmm the most number be 0, but don't matter. So this is the formula you have to use. What we're gonna do is just search the T, delta T. So what I did is just I put this there. Maybe I will place it like this so you can easily see the exercise. So I just from this part to did I put to T this part. Basically you will have this one, and you will have this one. Then you will have a final formula, and we'll do this. So this number it's just a seconds per hour, you know. How did I get this? I did just 265 times 24 hours times just how many seconds in a year, times 60 minutes times 60 seconds, and then it give me this one, you know, just for people that will know how I define this, then divided by 2 times the light speed, in skirts, then give me this, and it will give my this one. So what I did, I just put the units like this, and then I just write it here like 91, and it give me this one. We can also just write this and you will be fine. Okay. I hope you will do good. You will get good results in your exam. Don't forget that you have to fight for it. So I have much faith in you, in y'all. I mean, I believe in you. Go for it. Success. This was Mr. Ichigo Bankai mastering physics for you. And maybe to the next time. I will see what I will do with this channel. Maybe I will make some, video or we'll see.